Hello geometry students, this is Mr. Fugay, and in this video we are going to do an introduction to two-column proofs, and specifically in this video we're going to look at algebraic proofs. So this video is not going to provide a background of reasonings of why proofs exist and why we even need to do them in the first place. This video instead is going to take something we're very familiar with, solving algebraic equations, and I'm going to show you how we use what's called a two-column proof format. And so this is a formal way to be able to prove that something is true. So before we jump into actually how it's formatted and whatnot, we do need to just quickly review a few properties that you already know, but maybe don't know the name or have forgotten the names over time. So when we're solving an algebraic equation, all right, 2x plus 1 equals 10, for example. If we were solving that, what properties am I allowed to do to try to get x by itself? Well, the four most obvious ones are going to be using the operations. So addition, subtraction, multiplication, and division. And the idea here is if you have equation A equals B, I am permitted to add a C to both sides of that equation. And that is called the addition property of equality. All of these properties should say of equality after. We're not going to write that just because that's a lot of repetition. But the addition property tells me I can add something to both sides. Whereas subtraction allows me to do the same thing, multiplication allows me to multiply anything I want to both sides, and lastly, we're allowed to divide on both sides. So these are your four most basic properties of solving an equation. Now there is another group of properties we do need to talk about, and that is the reflexive, the symmetric, and the transitive properties. So quickly to explain them, the reflexive property, we're not going to get much into this video, but it's just the notion that a number is allowed to be equal to itself. 5 is indeed equal to 5. 12 is indeed equal to 12. And while that might seem very obvious, this is going to be a strategic property that we'll need to use down the road when we start working with geometric proofs. But we're going to leave it on the side for now. The next property is actually interesting because if you ever see a student write 10 equals x, and then you write x equals 10, you might say to yourself, is that the same thing? And for probably most of you, you're like, yeah, of course it's the same. You just flip it. Well, why are you allowed to flip it? You're allowed to flip an equation around using what we call the symmetric property. And then the last of these properties we call the transitive property. And this one's probably best through an example for me to show you. So we could say, for example, that if you have 25 cents, that we know that 25 cents is equal to 5 nickels. Okay. Do we also agree that let me go back and start this again. We can say that 25 cents is actually equal to 25 pennies. So if you agree with those first two statements, 25 cents is equal to 5 nickels and 25 cents is equal to 25 pennies, could we create a new equation where we say that 5 nickels must then equal 25 pennies? And if you feel like we can make that jump, what you just did in your head is you completed the transitive property. If you have two things that are equal to the same thing, in this case A and C are both equal to B, we can create a new equation saying that A is equal to C. And then the last two properties before we look at an example are the substitution property and the distributive property. The substitution property allows me to take, if I solve an equation for x equals 10, I can take that 10 and plug it back into the original equation to check my solution. That's what we call substitution, taking two things that are equal and swapping one for the other. And last but not least, we have our good old distributive property, which you're probably familiar with, and it's the idea that if you're multiplying over addition, that you would multiply each term. So how does this work for a proof? We have an equation here that you're probably familiar with in solving. 2x plus 5 equals 20 minus 3x. What I'm going to do is I'm going to create a two-column proof. I'm going to create the word statements and draw a line. I'm going to create one here called reasons. And that's a two-column proof. On the left-hand side, we're going to start with our original equation. 2x plus 5 equals 20 minus 3x. We're going to call this our given statement. This is what was given to me at the beginning of the problem. And now the question is, well, what can I do to solve this equation? And there's, of course, many different ways of doing this. The first step of which probably is that you're going to add 3x to both sides. Well, if I add 3x to both sides, what I'm going to end up creating is an equation that says 5x plus 5 equals 20. Well, what allowed me to do that? Well, looking back at our properties that we talked about, we just did what we call the addition property. So that is the reason why. So each of these new statements, how did I get that statement? I used the addition property. For the next one, I'm going to subtract 5 from both sides. So what would that be an example of? That's an example of the subtraction property. So let's write that down. Subtraction property. And then last but not least, we would divide both sides by 5 to create our final answer. And so that is going to give me x equals 3. So step 4 was created by using the division property. So do you see how this idea that what you probably would have shown for your work normally in a class is just this? What we're doing with a 2-column proof is not only are we writing out our problem, but we're given a reason of why each statement got to be the way it looks. So you start here, you work your way to step 2, you give your reason for it. And then once you're done that, you repeat. You find your next step, give me your reason, and you keep going until you reach your conclusion. Let's look at one final example, and then you will get a chance to try this yourself. So here is one more. It's a little bit more complicated. If you wanted to challenge yourself, you could certainly pause this video. We can write the equation out. So let's do that real quick. So let me write that out. You always start by writing out the beginning step. So in this case, the equation. And then we'll say given. That's our given statement. Now, what would you do from here? Pause this video and think about what you would do next and how you would solve this. And if you're staying with me or if you've tried it, let's take a look. I think the first most obvious thing is we're going to take that -4 and we're going to distribute it. So this becomes -44x minus 8 plus 3x equals 72 minus x. You might be very tempted to combine some steps together, but in a 2-column proof, you should only use one property at a time. So if you were thinking to yourself, oh, well, I'll distribute and I'll move that -x over, hang on, one step at a time. Now, here is one that I want to bring up that we've not mentioned in the video. On the left-hand side of this equation, I have a -44x and a positive 3x. On the same side of an equation, we are allowed to combine those together. So when I do that, we're going to end up with -41x minus 8 equals 72 minus x. Now, this wasn't listed up in the properties, but what this is the concept of combine like terms. So when you have variables or numbers on the same side, that's what you would do. And now from here, the rest of this problem will look very familiar to what we did in the first example. So I challenge you now that if you have not done the rest of this, go ahead and pause this video now and see if you can finish it using example 1 as a model. All right, we're back. And if you got the answer of x equals -2, that's great. So if your steps were a little different than mine, that's fine. The first thing that I decided to do was I decided to add x to both sides. And so when I did that, that's where I got my -40x from. Then after that, so that was addition property. Then after that, I decided to add 8 both sides. So that was another addition property, which allowed me to get -40x equals 80. And then my final step, I divided by -40. Notice I'm not showing the actual work. I'm just writing what the statements are. That's kind of a cleaner way of doing things. So I'm using my laser pointer to show you what I did, but I'm not actually writing it out. But we see that we get down to the very end. So now this is your opportunity to try and utilize a concept that you're mathematically comfortable with, but maybe a format that you're not comfortable with. And I would like you to move into this practice on the next page where there are 4 practice problems. And oh yeah, number 4 is a bit of a doozy. It's a bit of a challenge. Make sure to take your time. And for example, I'll give a hint. If you want to use the distributive property on both sides of the equation, you can do that in one step if you'd like, because it's being done to the entire equation at one time. It's a single property, one property at a time, that you can try that out. So 4 will definitely be your toughest one, but go ahead and give that a try using the 2-column proof format. Thank you all for watching.